Today we learn our next method of solving quadratic equations, and that is completing the square. Yesterday we did factoring, actually not yesterday, 2 days ago, we did factoring and extracting the square. Extracting the square. Those are the two methods that we've covered so far. This is our third method, completing the square. What I'm going to do first is I'm going to give you steps, all right, for completing the square. And it's a nice little system that works. Some students really wind up liking this one. Others don't like it as well. But you'll kind of find which one you like and go from there. If I am given x squared plus bx, okay, my first step is to take half of b. Okay, take half of the b term, that number in front of the x. And, you know, we could think of that as b over 2. All right? We are going to have to use fractions some when we complete the square. Number 2, square it. Actually, we are going to square both sides. Oh, I'm sorry. I'm sorry. Not square both sides. Square it. I don't know what happened to me there. What do I mean when I say square it? I mean square this. Okay? Then we are going to add what we squared to both sides. Okay? So this little b over 2 thing becomes very important when we're completing the square. That's what we're going to square, and then that's what we're going to add to both sides. Okay? And finally, it's going to kind of be like extracting the square root from there. Okay, we're going to square root and solve. Okay, you'll see the process works very nice, and let's go ahead and get to an example here. So we're going to solve by completing the square. Let's say that I have x squared plus 2x minus 6 equals 0. Well, the first thing we have to do is get it in the right format, which means if we go back to this, I had it written as x squared plus bx. So the first thing we want to do is add 6 to both sides and get it in that form where I have it as ax squared plus bx. So now I have x squared plus 2x. Here's a little tip for you. Leave a space and put your equal sign before you put the 6. The reason I said leave a space is because of what comes next. Okay? What we are going to do is we are going to take half of the b term. So here's my b term, right? So what is half of 2? 1. We are going to square it and add it to both sides. So I'm going to add 1 squared to both sides. All right? Now, the reason why that works is because of the square of a binomial. I told you that little shortcut's going to help us out later. Won't this thing right here factor real nice into x plus 1, the quantity squared? And when you're completing the square, everybody, here's another little tip for you. let me get a different color here. Leave this thing as, you know how we took half of the b term? Leave it as that quantity squared. You know why? Because that number is going to be this number right here. Okay? So don't go ahead and multiply out, you know, like if it's 3 squared, don't write a 9 there. Leave it as 3 squared. Because that 3 is what's going to go right there. Okay? So on the other side, I have that equals 7. And now it's basically an extracting the square root problem. Extracting the square. We're going to take the square root of both sides. Remember, this is going to be a plus or minus 7. Plus or minus the square root of 7. This is going to be x plus 1. Subtract 1 from both sides. X equals negative 1 plus or minus the square root of 7. And we know that that represents 2 answers. Okay? Let's do another one. X squared minus 16x plus 39 equals 0. I'm going to pause the video and let you try to tackle this one a little bit. All right, let's see how you did. First thing we should have done is take this 39 over. So now I have x squared minus 16x, leave a space, equals negative 39. I'm going to take half of this number, which is 8. Some people ask, should that be a negative 8? It doesn't matter because we're going to square it. All right? So half of 16 is 8. We are going to square it and add it to both sides. And that makes it real easy for me to factor this side as the square of a binomial, x minus 8 quantity squared equals, this is negative 39 plus 64. Isn't that 25? And now we can take the square root of both sides. So x minus 8 equals plus or minus 5. So this time we can actually come up with 2 number answers. You shouldn't leave it as 8 plus or minus 5. We can actually figure out what this is. This is x minus 8 equals 5, and x minus 8 equals negative 5. And just solve both of those. One of my answers is 13. The other one is 3. All right. Let's do one more, then we'll be done for the day on completing the square. 2x squared plus 8x plus 3 equals 0. This one's going to be a little bit more challenging because we're going to have to deal a little bit with fractions. Not real bad. But I want to go back to our very first page here. Notice something. When I said given this, is there an A here? No, it needs to be 1. So when we get to a problem like this one, and you see this 2 right here, you need to know that you're going to have to divide everything by 2 at some point. Whether you do that before or after you move the 3, it doesn't matter. I'll go ahead and move it. So now you have 2x squared plus 8x, big space, equals negative 3. But before we start completing the square, we have to divide everything by 2. Okay? So I need to divide this by 2, this by 2, this by 2. Now I have x squared plus 4x equals negative 3 halves. Okay? Everything else from this point on is the same. We do have to deal with the fraction over there. We're going to take half of the b term, which is 2, and we're going to square it and add it to both sides. So on this side, I'm going to add a 4. Well, how do I do that with fractions? We don't need a graphing calculator for that. That's negative 3 halves plus 8 halves, isn't it? Right? Isn't 4 the same thing as 8 halves? And then negative 3 plus 8 is 5, so this is 5/2. Okay? And then this, of course, factors into x plus 2, the quantity squared. We can take the square root of both sides. Take the square root equals the square root of 5/2. So x plus 2 equals plus or minus the square root of 5/2. Subtract 2, subtract 2. How would I write that answer? You know, I've got negative 2 plus or minus the square root of 5/2. I doubt your book would have the answer written that way. More than likely, what they would do is they would rationalize this denominator so that you would have negative 2 plus or minus the square root of 10 over 2. And I suppose that would be a little bit better. That's one way that it could be written. The other way that it could be written is to go ahead and get a common denominator. Isn't this negative 2 the same thing as negative 4 over 2? Isn't negative 4 over 2 the same thing as negative 2? So then you have negative 4 over 2 plus or minus the square root of 10 over 2. And I could then write it as negative 4 plus or minus the square root of 10 over 2. You need to be aware that sometimes the book will write the answer that way. And you need to know how to get there. Okay, so that's why I went over it. The only other thing I want to mention is that sometimes, just real quick, we're not going to finish this problem. You might have something like this. When I take half of the b term, what do I get if it's an odd number? Isn't this 5/2? So I'm going to add 5/2 squared to both sides. So on this side, that would be a 25/4. And how would that factor down here? That would factor into x plus 5/2 quantity squared. It still factors the same way. But when you work out the problem, you're going to have some fractions to deal with. And I really want all of you to work through these fractions by hand. You must get good at fractions without the calculator. You've just got to. So this would become what? Negative 68 over 4 plus 25 over 4. And then you could combine those two into what? Negative 43 over 4 and finish the problem. All right? But do not avoid fractions. Do not just rely on the graphing calculator. I know the graphing calculator will do fraction problems, but you need to be able, at this point in your math career, all of you need to be able to do stuff like this, okay, without the graphing calculator. And we're going to stop there for today.